Good evening to all. Is the video and audio clear for everyone? Okay. Thank you. So, coming to today's session, let me take a confirmation from your side that do you have any questions with regard to minimization problem and the big M method we have discussed in the previous session? We have discussed about big M method in the previous session in solving the minimization problem. Do you have any queries to anyone? Right. Please go ahead with your doubt. Why we have given S2 value means in the table we are building up S2 value for iterations, right? Is that your question? In answer, yeah, the thing is you are asking about the iteration procedure or at the final answer you are asking? Final answer. So the thing is, the only thing with regard to the objective of the other function is nothing but it is dependent on x1, x2 or x3, whatever the variables we have taken. The thing is, in the objective function, we will take even though s1, s2 values are obtained, they won't affect on the objective of the function. So what happens, these are slack variables or surplus variables, whatever you call. Before the start of the solution, we have to start with a basic point or basic solution, isn't it? So to start with the basic solution, S2 value will be like that. Maybe the tabular answer will be different. Okay, it is just for your understanding. Even though if you get S1, S2 values, they won't have any effect on the objective function, because in the objective function you have 0 is the coefficient for them. It won't affect the minimality or the maximality of the function, right? I will take more problems on simplex method too. So if you are interested, let me go for one more problem on simplex method minimization case. Just hold on a second, I will take a problem right now on minimization. Just hold on a second. Right. Now take the problem. I will give you the idea so that we will have a good understanding on big M method. So minimize z equals to 8x1 plus 6x2 subject to the constraints 400x1 plus 200x2 is greater than or equal to 8000 and 2x1 plus 4x2 is greater than or equal to 100. 80x1 plus 80x2 is greater than or equal to 2800. Well, x1, x2 are non-negative restrictions. How to find S2 value in previous question, right? So can I post the solution in detail in the group so that you can cross check that? Yeah, that I will do. Thank you. Because if you go with that concept, then this session will be somewhat disturbed. Right. The last problem, what I have given there, right? x1 plus x2 plus x3 is equal to something. The problem what I have mentioned there in the last session. Is that correct? You are asking about that problem? Say. Or what to start with S2 values you are asking? What are the basic value of S2 you are asking? Okay, we are getting different values of S2. Okay, right. Maybe the answer is given different. Don't worry. The answer is given different. If everyone agrees with one answer, that is okay, fine. So please post your S2 value. What you have obtained there. Is that 25/2 or something which you have posted? Sure, definitely. 31/2, right? Actually, my intention is after the completion of this simplex method and other concepts of linear programming, my next topic in linear programming would be transportation problem and assignment problems. So my intention is before to start this new concept under this linear programming, I want to give at least 20 to 25 questions regarding graphical method and all simplex methods, etc. So that you have a good understanding of all these concepts, and we will discuss at the last as a doubt clarifying session over these problems. That is my actual intention. If you are more interested, let us straight away go with previous year questions. You start them solving on your own. We will have one more doubt clarifying session over these previous year questions. That is my actual intention. I think the link is available in the group over previous year questions. Whole questions are there. You can solve right from beginning 1992 to till 2017. All questions are available in the PDF format. Right. So if you are not good, I will ask them to post in the group the PDF for these LPP problems taken from the previous year questions. Is that okay? So before going to take an assignment from my side, if you straight away go with previous year questions after seeing the class sessions, so we will have a good discussion in the class. So what are the difficulties you are facing in solving these questions, we can discuss. That is my actual motto. And one more thing, since you are solving the previous year questions, you will have the confidence and you can share the solutions with other people in the group so that whoever are not getting the correct answer, they will share the solution. It will be a collaborative approach. That is why I am not giving any assignments for you separately. I am mainly focusing on the class session. How good you are understanding the concept in solving a problem. Is that acceptable to everyone? Because everyone has to concentrate apart from this math optional, general studies and other things also, right? So that I am keeping you of the time constraint. My intention is this. So if you understand a concept well, there is no need to go for more and more practice for some particular topics, not all. So let us go with the problem first. So if this is the minimization problem, since it contains three inequalities, or of greater than or equal to type, we need to introduce three surplus variables as well as three artificial variables here. So the canonical form will come as, or the standard form you can call, (2x1 plus 4x2 minus s2 plus a2 is equal to 100). 80x1 plus 80x2 minus s3 plus a3 is equal to 2800, and the objective function will come as minimum z is equal to 8x1 plus 6x2 plus 0s1 plus 0s2 plus 0s3 plus ma1 MA2, MA3. A stands for the artificial variables. You can use the symbol R also. That's a good question. Whenever Cj minus Zj values have a tie, please understand one thing, that we are doing very small problems. Say 3 variables, 4 variables. In the examination point of view, we are solving. If you take a real life situation where we are going to discuss with at least n variables, say 10 variables are there, you are going to deal with x1 to x10, definitely a tie will come among Cj minus Zj. So while choosing the key column, it is arbitrary choice to select the key column, because if you take one column selection here, in the next iteration it will be eliminated, right? So that you will get a breakthrough always. A tie will happen always. So selection of key column is arbitrary if there is a tie. Let me say, after calculating Cj minus Zj, you will have the values as 8, 8 and 6. If you are going with the most positive one, you have 2 8s. Where to start with the key column? Is that your question, right? You can select either of the things, either this one or this one. Because if you select this one, one variable is eliminated here. In the next iteration, it is going to be eliminated, right? Because we are going with the elimination process. That's it. Always a tie will happen. A tie will come always if you deal with more number of variables. Fine. So is the canonical form correct? Do you accept with this thing? Everyone? If you are correct, then I go with the simplex table formation. Shall I? Fine. Any queries for anybody in writing this type of notation? Introducing the artificial variables as well as surplus variables? Any queries to anyone? So we are saying that apart from taking this large number of things, so if you divide with 200, you are going to take somewhat different. Equation will be reduced. Yeah. So practically you take the situation that suppose this is nothing but 400 grams of one medicine. This is 200 grams of another medicine, right? So equal to this thing 8000, the constraint greater than or equal to. If such is the case, if we divide, will this satisfy the real life situation? 200 grams plus 100 grams. So practically, if we divide for a real life situation, it is not correct. If you want to solve a problem, you can solve, but actually it is not correct. You have to take the same coefficients as it is. Fine. So the difficulty in simplex table is, if we have large coefficients in the inequalities, simplification takes a little time. And tedious procedure in calculating step-by-step iterations under simplex table. Fine. Now I am taking the solution part. If you read the objective constraints, it will be 8, 6, 0, 0, 0, m, solution, and you have the ratio, right? So on coming to the variables, you are taking x1, x2, s1, s2, s3, a1, a2, a3, and coming to the values from the table, you are going to get them as 400, 200, minus 1, 0, 0, 1, 0, 0. And the solution value is 8000 here. And again here, 2, 4, 0, minus 1, 0, 0, 1, 0. And the value is 100. And then 80, 80, 0, 0, minus 1, 0, 0, 1. And here you have 2800. and you are doing the iterations with A1, A2, A3 with coefficients m. These are CJ values, these are basic values, basic variables, basic coefficients. Is this clear now for everyone? You can just observe one thing, that whether you have a identity matrix setup, either in the case of artificial variables or slack or surplus variables. If you don't have such type of situation, means the canonical form or the form which you have written is not correct. That is the outline concept. Right. So if you calculate ZJ values, it will be little difficult. 482m, 284m, and you have the other values, minus m will come. And if you calculate Cj minus Zj, you are going to take the values as, this will be 8 minus 482m, and this will be 6 minus 284m, and this will be m, 0, 0, 0. Which of the entries of table has to be converted into identity matrix terms? Let us do like this. Now you just give an inequality to me so that I will frame the tabular data. The confusion will be avoided. So don't give the objective function, give me the inequalities. Whatever you want, either in 2 variables or 3 variables, you give it to me. Is the thing acceptable for everyone? Fine. And every time we have to doubt that while doing the iterations, what are the variables we have to take here? That is one common doubt for everyone. I hope so. Is that right? Yes. The thing is, after writing this canonical form, I will say that everyone is clear what are the slack variables, surplus variables, and artificial variables in order to convert either less than or equal to or greater than or equal to equal to. Am I correct with this? I think everyone is known with these notations. How to introduce the variables to balance the equations. Yes or no? If you have given a less than or equal to inequality, right? Sorry. So what happens after entering the values in the tabular data? If you want to know what variables table taken care of here, it is very simple that in this, except from these technological coefficients, you will have the other coefficients here, either slack, surplus, or artificial. Now, in these variables, you pick up the variables whose coefficient is 1. So here, S1 has coefficient -1, we won't consider this. S2 -1 we won't consider. S3 -1 we won't consider. So A1 has coefficient 1, A2 has coefficient 1, A3 has coefficient 1. That's all. So that we will take them. Clear now? I will give one more modification that, let me say, I have gone a column like this. Now see, where is the identity matrix setup here? What are the variables we are going to take here? So S1 has a value 1, we should take S1. A1 has value 1, so we should take A1. A2 has value 1, so we should take A2. So in the iteration table, these things will come, S1, A1, A2. These things will come. Does it make sense? What are the values we are going to take for iterations? Because on writing this, we can observe that if a variable has value 1 in one equation, it always gets 0 in the other equations. It won't get 1 at anywhere. In such way only we are writing the equation setup. Accepted. Yes or no? Any more queries for anybody? Right. In a simple manner, I can say one more thing. Without any ambiguity, let us say somewhat cut short. If this is the setup we have got, so what are the variables we are going to take for iteration procedure? Please say. Exactly. Because S2 has coefficient 1 and A1 has coefficient 1. So that in the iteration column, you will get S2 and A1. S1 will not be there in the iteration procedure. I think this will clarify the doubt. What are the things we are going to enter here for performing iterations? Accepted to all? That is also acceptable. The way what you have written is, okay, if you are very particular about the order, take A1 and S2. No problem at all. If you are very particular in the order, because in the first row, the one coefficient is taken for A1. In the second row, one coefficient is taken for S2. So A1, S2 is the order. The particular order we can say. Accepted to all? Fine. Yes, one less than and one greater than the thing I have taken. So from these two we can say that S1 and A1 are taken for one single inequality which is of greater than or equal to. Here S2 is taken from the second inequality, so it is of less than or equal to. I have only two inequalities. Right. I think the whole idea is clear for everyone in selecting the variables and writing this type of form. Okay. So can I proceed with the solution part then for this? So since the objective function is minimization here, we have to go for greater than or equal to for all the values of Cj minus Zj. So positive, 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 0, 0, 0. Here it is okay. Here you have two negative values, among which what we have to choose? Minus 482m, because this is minus m, this is minus m. While comparing the coefficients, 482 is larger than 284. So this will be the key column. So to get the key element, these solution values are divided with this one. So 8000 by 4400, it will be what I am writing here, 20, and here you have 50, and then have 2800 divided by 80. What will be the value there? Right, 35. So among all these things, this ratio is minimum. So this will be the pivot element. Now this whole row is divided with 400, and according to this only we are going to change these rows. And A1 is replaced with X1 and M is replaced with 8. So since these values are known, I am going to erase these values. I will build the next table here only. So you are going to take it as X1 with 8, A2 with M, A3 with M, and this whole thing is divided with 400. So this will be 1 by 2, minus 1 by 400, 0, 0, 1 by 400, 0, 0 and 20. Clear? Is it acceptable? Right. And as I have mentioned earlier, to avoid computational difficulty, since A1 is replaced, I simply put a blank here. So that once an artificial variable is removed, it will not come in the further iterations. So to avoid the computational difference, I will put like that. Accepted to all. Right. So do you have any confusion in calculating the further rows? If so, I will take one more performation here. Otherwise, I will fill the gaps of the table. What do you say? So one of our friends that R2 tends to R2 minus 2 R1 because this element will be made 0 by using the new elements here, not of these elements. We are making choice of this row. So R2 tends to R2 minus 2 R1. Accepted to all? Any queries in performing the modification of rows? If so, I will write down here. If there is no query, I will fill the gaps of the table. What do you say? Shall I proceed with filling the gaps, or you want to know how the modification will be done? Fine, I will fill the gaps. So it will be 0, 3, 1 by 200, minus 1, 0, 1, 0, and you have 60 here. And coming for the next thing, it will be 0, 40, 1 by 5, 0, minus 1, 0, 1, and you have the value 1200 here. Now I left the task for you to calculate Zj as well as Cj minus Zj and tell me which is to be taken as the key column now. Clear to all? I will write 0 here without any confusion. 1, 0. That's it. This will be dash. And this will be 60. So that alignment will be in good position. So if you calculate Zj values, it will be 8. It will be 4 plus 3m, 4 plus 43m. And you have other values like that you are going to get. So the difficulty in this method is, while calculating Zj and Cj minus Zj, calculating with m gives a difficulty for us. Sometimes you will get fractions also here, 22 by 7 into m, minus 81 by 2 into m, like that. So these fractions will give time complexity for solving the problem. Otherwise, the procedure is convenient in solving the iterations and getting the next table. Accepted? So I will say that next we are going to take this thing as key column. Will you agree? Is anyone has any doubt? So to show the complexity of this linear programming, I have taken the problem like this with big coefficients. So this much of complexity you can expect in UPSC exam. On the outline, if you think of simplest method, it is just writing a simultaneous system of equations, solving using row operations by table by table. So if you are good enough in filling the gaps of the table, then you are done. So it takes time when the coefficients are big in number. That's it. Otherwise, it is just a process of applying row operations every time. Accepted? Right? If the process is clear for everyone, then I skip the problem. Straight away I will write the final solution by writing the next table. Or if you are interested in performing these calculations, we can go. No problem at all. Right? So I will make space here. So later we are going to replace, and the thing will come like this: x1, x2, a3, 8, 6, m, and the corresponding values will be taken like this: 1, 0, minus 1 by 300, 1 by 6, 0. Two variables are removed here, 0, and you have the value 10, solution value, and then you have 0, 1, 1 by 600, minus 1 by 3, 0. Two things are removed here, again 0 here, and you have the 20 is the solution, and then here you have 400, sorry, 0, 0, 2 by 5, 40 by 3, minus 1, and then 1, and here the value 400. So if you go for the next iteration table, it will come like this. So if you perform the calculations, calculating Zj and Cj minus Zj, the slack or surplus variable columns will be removed by S2, the column. So from Zj, it is clear what should be pivot element. Do we need to calculate Cj minus Zj? Please understand one thing, that if the value of Zj coincides with the top row, that is the objective constraint row, so what happens there? You are going to check the optimality is achieved or not. That's why we are performing Cj minus Zj. So after calculating Zj, immediately how do we know that optimality is achieved? Without taking the difference between the top row and the current Zj row. So it is a checking criteria for optimality. Sometimes what happens, okay, I will take the change, right, 2 by 15, thank you. So where I am, right. Sometimes what happens, the variables will not get removed and the optimality is achieved. So at this point, I want to mention one important thing, that see, after performing these iterations, in general, artificial variables will be removed in the iteration process and we will get the final solution there, right? Sometimes if the artificial variable is presented there, it means that the system is infeasible, so there is no solution for the given problem. Slack variables may be present, but artificial variables must be eliminated completely in the iteration process. However, if there is a variable which remains still, means it has infeasible solution, we say that it has no solution, the system has. That is the conclusion while doing the problem under artificial variables. In general, for most of the problems, it will be eliminated while performing the tables. Fine. So after getting solution, after the last iteration, how do we determine all basic feasible solutions, all basic solutions, a feasible solution which is not a basic feasible solution, right? So immediately I will say that the table is set up like S1, S2, S3, or these are the basic feasible solutions. Let me say like that. The variables we are taking here, x1, x2, a3, are nothing but the basic feasible solutions. So after that, what happens? They will become as non-basic, and you are finding the correct solution or the optimal solution of the given problem. Let me say like this. Suppose you have written an inequality like of the form x1 plus x2 less than or equal to 200. So what happens? We will write like this: x1 plus x2 plus s1 equal to 200 to balance the equation. So if you put x1 and x2 as 0, s1 is equal to 200 is a solution. It is just like one of the points in the graph if you draw. Accept it. So if you draw x1 plus x2 less than or equal to 200 as a graph, how will it come? You are going to get a straight line like this. Accept it. So to get the identity matrix setup, we are introducing these variables. But however, S1 is equal to 200 is a basic solution, just like 200 comma 0 and 0 comma 200 are one of the points, nothing but the basic points of the solution, right? In the graph, if you consider. So it is just like that. We have set up a basis, nothing but the basic feasible solution for the LPP. Using that solution, by calculating the further iterations, we are modifying the solution and getting the optimal solution. That is the underlying idea. So without starting a basic feasible solution, we are not going further. Clear now? The variables on which you are performing the iterations are nothing but the basic feasible points, satisfying the constraints. Fine. Okay. By taking the graph. So let us take a simple thing that, let's say 10. I have known that question 2003. So what are the basic solutions? I want to discuss that problem separately. Would you mind? Can I? Because I want to go with the class, because there is a separate thing posted that we are going to discuss on the problem of dual today. Otherwise, the motive will be purely on the doubt clarification. Thank you. Right. I hope that everyone is clear with this minimization concept and maximization concept and building the simplex table. I will left with you. We can cross check in the group. Fine. So because if I post the answer again, there is a doubt where it is being done. Fine. So my concept is the concept of dual in linear programming. Let me say, to get some interest over the concept, I want to take a situation for your consideration. So let me say, I have a doctor and a patient consulted the doctor because of his sickness. So the doctor counseled the patient, examined him, and observed that his sickness is because of vitamin deficiency. So what happens? On examination, the doctor suggested that, so these are the vitamins which are deficient for you. So you take these vitamin tonics or vitamin supplements so that your health will be improved. This is the situation. Accepted? Yes or no? Are you getting the logic or not? So the doctor has given the prescription and the patient has to purchase some medicines in the shop. Now I am going to give the detail like this. The patient has a deficiency of vitamins A and B. As and when he goes to the shop, there are two tonics or two products, let me say, in which these vitamins are presented in different proportions. So I will say that, so if for our convenience, I want to give the notation like vitamin X and vitamin Y and the tonics A and B. So if you take tonic A, it consists of 2 units of vitamin X and 3 units of vitamin Y. If you take tonic B, it contains 4 units of vitamin X and 2 units of vitamin Y. And both of the tonics are available in the medical shop. Now, I am the shop owner. I am going to sell the tonics to the patients. Now, what happens if I sell tonic A, right? The cost of tonic A is 3 rupees and the cost of tonic B is 2.5 rupees. This is the real-time situation. Are you getting the concept or not? And one more thing is, the doctor advised to take maximum at least 40 units of vitamin X and 50 units of vitamin Y every day. I have taken this situation to introduce the concept of GL for you under linear programming. Is the tabular data understandable for you? Any queries for anybody? Fine. Now, here we have two situations. One perspective is, I am the patient, my point of view. Since I am a patient, my purpose to be survived, that is, I should purchase the tonics, get the best of vitamins, and cost should be minimum. Accepted? Because I am the purchaser, isn't it? Right. So if you take the medical shop owner perspective, since he is selling the goods to get maximum profit, he want to improve his sales. So his concept is maximization of the sales. Accepted? So for one single real-time situation, we have two perspectives, nothing but two objectives. So in the perspective of shopkeeper, we can formulate a problem. In the perspective of the patient, we can formulate the problem using this data. So what happened? One problem is the transpose of the other problem, because they are interconnected, vice versa. Yes or no? So if I construct the LP formulation for the patient, it will come like this. Since I am the purchaser, I want to minimize my cost. So if I take the patient perspective, I want to minimize the cost. So tonic A cost 3 rupees, tonic B cost 2.5 rupees. It will be 3A plus 2.5B minimization in the perspective of the patient. And what happens? He mentioned that at least 40 units of vitamin X and 50 units of vitamin Y. So X is presented in this portion 2 and 4. So I will say that 2A plus 4B must be greater than or equal to 40, and 3A plus 2B must be greater than or equal to 50, where A comma B are greater than or equal to 0. Accepted to all in formulation of the content. Any queries in formulating this? For vitamin X, minimum availability must be 40. So X is presented here 2 and 4. 2 in A, 4 in B. So 2A plus 4B is greater than or equal to 40. Similarly, vitamin Y is presented 3 units in A, 2 units in B. So 3A plus 2B is greater than or equal to 50. In this way, I have formulated the problem. So this is the perspective of the patient. Now I am going the perspective of the shopkeeper. So what I have to do? I have to maximize my profit or maximize my sales. So the doctor advised that 40 at least you should take, 50 at least you should take, 40 units and 50 units. So maximize the number of units, say 40x plus 50y, or you can use other symbols, say 40p plus 50q. That is your choice, right? Subject to the constraints that this is the perspective of the shop owner. Because the patient should take at least 40 and at least 50. So if you will take more and more number of units, it will be a profit thing for you. So maximize the more of these things. So I just want to say the outline of the problem is this and this matrix are transpose, you can observe. And here these coefficients appeared on the right hand side. These coefficients appeared here on the right hand side. Are you observing? So the thing is, whenever you have a real-time situation, you are formulating the LP problem by means of a perspective. By which perspective you are formulating a problem? So for this situation, you have two perspectives. One is the patient, another one is the shop owner. So one person's aspect is to maximize the sales, other person's is to minimize the cost to satisfy the required criteria. So on the whole, I am going to say that whenever a minimization problem is there, that corresponding problem you can formulate into another one, and if you solve this problem, at the same time you are getting the solution of the previous problem also, because they are interconnected. So the first problem what we are taking, we are calling it as the primal problem, and the other problem which we have formulated, we are calling it as the dual problem. So one solution of this will give the solution of the other also. So you can find the solution of primal from the dual as well as the solution of dual from the primal. They are interconnected. So why this concept is important? since you have a minimization problem, there you are going to introduce more number of variables, surplus variables as well as artificial variables, which takes more time in performing the iterations and building the tables. So to avoid that, if you construct the dual of the given problem, so since it is the minimization case, there you have maximization having less than or equal to symbol. So number of variables are very less, and you are going to solve the problem within short span of time, so that one solution will interpret the other solution, so both will be solved at a time. To avoid the computational difficulty, this concept is introduced, the concept of dual. So the given problem will be formulated into another LP problem, which is called dual of the original problem, and we are going to solve that. Fine. So if you are clear with this concept, let me take the problem first. How to construct a dual when a given problem is there. Then we go on to discuss. Solution is purely based on simplex method. We will solve the problem by means of simplex method. The only thing is conversion of one LP problem into another LP problem. That is the main aim. Okay? Right. Generally, in the examination point of view, the data will not be given to you, only equations are given to you. I mean the inequalities. So based on the inequalities, we are solving the problem. There is no need to formulate LP from the given set of data, and there is no need to formulate the inequalities on your own in general. The type of problems won't be given in exam. So let us take this situation. Maximum Z 23x plus 32y with the conditions that 10x plus 6y is less than or equal to 2500, 5x plus 10y is less than or equal to 2000, x plus 2y is less than or equal to 500, where x comma y are greater than or equal to 0. This is the problem which is given there. So we are calling this problem as the primal problem. And we are going to build the dual for this problem. So let us observe how to construct the dual when a given problem is there. Fine. Right. Now please observe how many constraints are there. We have three inequalities. So you will take three variables, say y1, y2, y3. Or you can take ABC also. If you are comfortable with ABC, let us take ABC. Now what happens while the construction, the right side coefficients will appear in the objective function. So objective function here is, since it is maximization, we are taking the opposite, it will be the minimization. So minimum Z is the objective function. These things will come in the objective function part. So 2500A plus 2000B plus 500C. Clear? How it is written? The objective function. Now, in order to take the respective constraints, take the transpose of this matrix. Nothing but you simply take the columns 10, 5, 1. So 10, 5, 1. So A, B, C. So this corresponds to the first one, because first column is taken with the first constraint. This will be 23. As we know, under maximization, all the inequalities of the form less than or equal to. So under minimization, all the inequalities must be greater than or equal to. So we will write greater than or equal to 23. In a shorter manner, in the primal problem, the coefficients in the objective function will come on the RHS in the dual problem. Similarly, if you take this column, it will be 6, 10, 2. So 6a plus 10b plus 2c is greater than or equal to 32. And always a, b, c are greater than or equal to 0. Right. For convenience, let me say, please check 10, 6, 5, 10, 1, 2. This is a matrix associated with these symbols. Accepted? So we are taking the transpose of this matrix. So row will come as column, column will come as row. So we will write like this: 10, 5, 1. 6, 10, 12. You will write the values ABC. So these right hand side constants will come in the objective function, and these things will come here. First column corresponds to the first coefficient, second column corresponds to the second coefficient. So in general, how many inequalities are there? That much number of symbols will come in the dual problem, the variables. Since it has 3 inequalities, we are going to get 3 variables in the dual. See, as we have discussed the patient-doctor problem, if one person's aim is to minimize cost, other person's aim is to maximize sales, so these constants will come in the objective side. Because if you take the patient case, it mentioned that some A plus B is greater than or equal to 40, minimum number of vitamins required. If you consider dual problem, these things will come in the objective, because he has to purchase maximum number of these vitamins. Here he has to take minimum number of these vitamins. He want to take the minimum number. The salesman want to say maximum number of these vitamins. That's why these constants will come in the objective portion. Clear? That's why I have taken the situation for you to get the ideology. The patient perspective is to purchase tonics A and B, so that minimum 40 of vitamin X, minimum 50 of vitamin Y he want to take. But the salesman aspect is the patient should purchase maximum number of 40 and maximum number of 50. That's why these constants will come in the objective portion while shifting up the situation. Clear? I think the concept is clear for everyone. Why primal and dual are important in LP. So I want to dedicate the thing for, I am going to give some set of problems and we are going to write dual for them, so that there is no confusion in writing the dual problem. Solution is common under simplest method that I am going to discuss in the next class or this session based on your understanding for the conversion of the problem. Okay? Clear to all? Shall I continue? Thank you. So this is my next one. Construction of primal as well the dual. So this is my primal problem, the problem which is given. So minimum z equals to 10x plus 12y, subject to the constraints that x plus 2y is greater than or equal to 2, 3x plus 4y is greater than or equal to 3, and x comma y greater than or equal to 0. Now you are going to give me the dual. So are you with me? So let us do with the dual, right? So in a first sense, since we have two inequalities are there, you take two variables a comma b, a and b. So what happens? The objective function will come as the right hand side of these inequalities must come in the objective. So 2a plus 3b is my objective thing, and since it is minimization, the objective function is to maximize z, subject to the constraints that if you take the first column 1a plus 3b, which is less than or equal to 10, take the second column 2a plus 4b is less than or equal to 12, where a comma b are greater than or equal to 0. Accepted? Please check on that. Any queries for anybody in conversion of all primal to dual? Right. So far we have done all the inequalities with only one type of symbol, either less than or equal to or greater than or equal to. Now what to do if there are mixed type of constraints? Let us go with such type of situation. Okay. Fine. So let us take the case that this is my primal problem. Maximize z, say 2a plus 3b, subject to the constraints that a plus 4b is less than or equal to 10 and 2a plus 3b is greater than or equal to 12. Now see the difference for the previous problem and this problem. Accepted. Now what happens? Before writing the dual, always make sure that if the objective function is maximization, all the inequalities must be of the type less than or equal to. If there is an inequality which is violating this type of thing, so that is greater than or equal to APS, so you simply multiply both sides with -1 so that it will be converted into less than or equal to. So we will write these equations as a plus 4b is less than or equal to 10 and -2a minus 3b is less than or equal to -12. Clear? So objective function is maximization and all the inequalities are of the type less than or equal to. So the regular form is obtained here. Now based on these inequalities, I am going to write the dual problem. So how the dual comes? So you take this is x and this is y. So the two things will appear in the objective function. It is maximization, so that should be minimization. So minimum z 10x minus 12y, right? Subject to the constraints that x minus 2y is less than or equal to 2, 4x minus 3y is less than or equal to 3. This is my dual problem. Please check on that. how it is formulated. So we are doing the multiplication with -1. Oh, sorry. Right. We are doing with the modification as and when a inequality which is not on the regular form. For that only we are changing. Rest of the inequalities will be holded as it is. Clear? Right? Let me take something interest for this, so that you have a very clear idea. Shall I proceed for the next problem in the conversion of primal to dual? Fine. So this is the problem. Maximize z 2x plus 3y such that x plus 2y is greater than or equal to 10, 2x plus 2y equal to 20. Now see the difference. Have you seen the difference here? Now, how to write the corresponding dual? Now here what happens? The maximization function will be as it is, maximum z 2x plus 3y. This thing by multiplying with -1, I am going to write it as minus x minus 2y is less than or equal to -10. Now how to do about this equality? There is no less than, no greater than presented here. How to do that? Now if I say a is equal to b, it means that a less than or equal to b and a greater than or equal to b. Accepted? If this situation is happened, then only a is equal to b becomes. Yes or no? So this equality I am going to write it as 2x plus 2y is less than or equal to 20 and 2x plus 2y is greater than or equal to 20. So whenever equality is presented, I am going to write this equal to as two inequalities. Clear for all? Yes or no? Fine. Now, since under maximization, all the constraints must be of the type less than or equal to. Since greater than or equal to is presented here, I am going to multiply with minus. So minus, minus, less than or equal to minus. Now, the regular maximization form is appeared there. So any queries so far in getting this conversion to anyone? Right. Now, based on this maximization taken as primal problem, I am going to build the dual. So you can take the respective values as A, B, C. Now you are going to take the corresponding dual. So it will be minimum z. These things will come in the objective function. So minus 10a plus 20b minus 20c, subject to the constraints minus a plus 2b minus 2c is greater than or equal to 2, and then minus 2a plus 2b minus 2c is greater than or equal to 3. Clear? where A, B, C are greater than or equal to 0. Now you can further modify the setup as C. It contains B minus C and B minus C as fixed. And you can observe that they have the same coefficients plus 2, minus 2, plus 2, minus 2. So for convenience, you can write that put B minus C is equal to say B. So how it will look like? Minimum Z minus 10A plus 20B. Subject to the constraints minus A plus 2B is greater than or equal to 2, minus 2A plus 2B is greater than or equal to 3. Do you accept for this simplification? Or you can keep like this as it is, no problem at all. So this is the conversion from primal to dual whenever equality is presented there. Fine. So now I am going to ask any doubts so far for you in this conversion, or if you have any other queries so far. In the conversion. Right? If you are clear with this, can I go with a problem? Fine. So let me take a problem. So take the problem that minimum Z equals to 24x1 plus 30x2 subject to the constraints 2x1 plus 3x2 is greater than or equal to 10, 4x1 plus 9x2 is greater than or equal to 15, and 6x1 plus 6x2 is greater than or equal to 20, where x1 comma x2 are greater than or equal to 0. I think you are able to write the dual for it. Now you can observe that if you want to solve the same problem, the primal problem which is given there in the problem, since it contains 3 greater than or equal to inequalities, you are going to introduce the 3 variables minus s1 plus a1, minus s2 plus a2, minus s3 plus a3, which increases the length of the table. Accepted? So that you are going to do the computation for more time. Now I am going to write the corresponding dual for it in solving. So maximum Z such that 10A plus 15B plus 20C subject to the constraints 2A plus 4B plus 6C less than or equal to 24, and then 3A plus 9B plus 6C is less than or equal to 30, where ABC values are greater than or equal to 0. Now you can understand that since there are two inequalities which are of the type less than or equal to, we are just taking only two variables S1 and S2 to solve the system under simplex method. Agreed? So that you can understand that there you are performing the solution by introducing three variables A1, A2, A3. Here you are performing the solution by simply taking only two variables S1 and S2. Now see how much reduction is there in the computational procedure. Accepted or not? All of you agree for this? Right. Now I am going to go for this simplex table. Shall I? Fine. So let me write the canonical form for it. 2a plus 4b plus 6c plus S1 equal to 24. 3a plus 9b plus 6c plus S2 equal to 30. And the objective function will come as maximum z 10a plus 15b plus 20c plus 0 S1 plus 0 S2. I am using the simplex method. So if you are interested, I will leave the problem for you in getting the solution. I will say you are going to construct the basic table and two more tables. So after the third table, you will get the optimal solution for the maximization problem what we have taken. Fine. I will give the solution for you. Shall I? Because you know how to build the table and do the iterations. Did anyone has any doubt with regard to solving the problem in building the simplex table? Okay. So this is the final table of simplex. I will say C and A will come. The values are taken as so this is the final table of simplex. Please check on that. I think you are also getting the same table on your end after doing these iterations. Okay. Now I want to mention one thing that from this table we have a solution for the dual. What is the solution? I have taken three variables A, B, C. A has value 6, B has value 0, and C has value 2, and the Z value is 100. Clear? Yes or no? Because objective function is 10 into A plus 15 into B plus 20 into C. Right. I will write the function also for convenience. Now, using this final table, we can depict the solution of the primal. So using the final table of simplex under dual, we can find the solution of the primal. That is one interesting aspect here. So how to find the solution of it? It is very simple. In the first simplex table, what are the variables we are considering to perform iterations? S1 and S2, isn't it? After writing the dual, in building the simplex table, we are performing iterations using S1 and S2. Accepted to all? Yes or no? Fine. So you forget about all these things. Here for S1 and S2, you take the values of Cj minus Zj here. This is the value 0. This is the value minus 10 by 3. So S1, S2 values are taken by taking minus symbol here. So you will write S1, S2, taking minus symbol to these things, 0, 10 by 3. In the primal problem, we have three variables, say x1, x2, x3. So you will simply write like this, x1, x2, x3. So x1 value is 0, x3 value is 0, x2 value is 10 by 3. So if you find the solution in the objective function of the primal, you substitute these values, which is the solution of the primal. Here, what I am doing, I am taking the values of the basic variables here in the final table of the simplex. I am going to the row of Cj minus Zj. So for these basic variables, what are the values obtained here? I am considering them with negative sign, this and this, because primal and dual are one after the other opposite values. Primal is opposite to dual and dual is opposite to primal. So we are taking the minus symbol here. So I have written S1, S2. S1 has value 0, say this is x1. X2 has value 10 by 3, this is x2. The same order we will take, because in the same order the constants are written in the primal problem. So if you substitute these values, this is also 0. If you substitute these values in the primal problem, you will get the same solution for the primal. Fine. So what are the solution of the primal if you substitute? 100. That's it. So in one way we can say that primal and dual have the almost same solution. Okay. It means that if you take the patient and the shop owner case, in exam, as and when the question asked that from the dual problem interpret primal solution, then only we will write. Otherwise, writing dual, solving the solution, getting the solution is enough. That's all. There is no need to interpret primal from the dual. They won't ask. If at all they ask, then only we will write the solution of the primal. Yeah, just tell me what are the variables in the primal problem, x1, x2, x3, isn't it? Right. So you just write like this, x1, x2, x3. What are the, yes, can we substitute like that with values of artificial variables? Definitely. Please understand, in the first simplex table, what are the variables we are using to perform the iterations that we are considering actually. Those values are taken exactly and corresponding primary variables are written exactly in the down. And the values of Cj minus Zj will be taken for the solution. That's the thing, not more than that. So x1, x2, x3 are the variables in primal. Here, in the first simplex table of the GL, S1, S2 are basic variables. You simply write S1, S2 here. Since S3 is not there, you simply put a dash here. And what are the values of S1, S2 in GL? 0 and minus 10 by 3. You take minus sign for them. So 0 and 10 by 3. So x1 value is 0, x2 value is 10 by 3, x3 value is 0 for primal. That's all. That is the thing I am mentioning. Okay? Right. I will give one small clarity that suppose in GL you have the variables like this. You have the corresponding Cj minus Zj values are taken. You take the corresponding same variables of the primal. That's it. Fine. That will give the solution of the primal. Okay. So let us wind up our session here. So if you're interested, I'm going to take one or two problems on GL. If not, I will go with the two-phase method, which completes the linear programming and simplex concepts. Okay. You please go ahead with the previous year question papers. Order of variables will matter the solution. That's why we are taking the variables equality wise, right? So in the equality wise only we are writing that. Because in every inequality, we will have one basic variable. Either it may be S1 or A1. So in the same order, we are writing the solution. Let me say, first equality is S1, second is A1, third is S2. In the same order, we will write. We won't change the order. Clear? Right. Thank you. So let us wind up our session here. If anybody has any other queries, you can ask. Exactly. The same identity matrix we are going to get the diagonal elements. First row, first element, second row, second element, third row, third element. That's it. That will avoid the ambiguity and confusion. I hope so. Thanks to all. So do you need any more clarity with regard to the explanation part is concerned to anyone? Or is that suffice? Say. I think you are able to solve the problem on your own by writing the form. Right? Thanks to all. That's all for today.